Hi, this is Xander Scott from Thursday's lab at 10 a.m., demoing for Lab 12, Nanoprocessor. So what we have for this lab is we have a total of 10 switches. We have our first 4 switches are our keypad or data switches. And this is the data that we are directly putting into the circuit. The next 2 switches over, that would be switches 4 and 5, are going to be our register switches, which choose which register we are inputting or outputting data to or from. Our last 4 switches are our instruction switches, which are they control the binary codes that access which instruction we will be using. So any of the outputs or inputs or anything will be controlled by those 4 switches. So, first of all, and we also have our clock on key 0, and we have the clear switch on key 1. So, first, our first instruction was to load 1 into R1. So, the instruction binary code to do so was 1, 1, 1, 1. For the data switches, that will, or for the register switches, that will be 0, 1. And then we're loading 1. And now that I've hit the clock button, it should be loaded in. I can verify that by turning off the data and switching our instruction binary code to 1011 is the output from the register that we have selected. And as we can see, that shows 1. Next, we want to load 2 into R2. So again, the input into a register is going to be 1111 for the binary code. Then we have 10 for the register selected, and then we have 0010 for the data. And we'll clock to load that again, turn off the data, and then we can output again with 1011. And as we can see, that is showing that 2 is loaded into register 2. So now we want to do the same for register 3, where we will load in 3 into register 3. So we want again 1111, and then register 11 and data 0011. Clock and turn off the data again. And again, the output is 1011, which we can see 3 is loaded into register 3. And then next, we will load 5 into the accumulator. The accumulator is the storage unit for the arithmetic logic unit. So let's go ahead, and the code to load into the accumulator is 1110. We're not using registers, so both of the register switches can be turned off. And we're loading 5 into the accumulator. So that is 0101. Load. And turn the data switches off. And then we can output, the output code to pull from the accumulator is 1010. So 10 and 10. And as we can see, the output is in fact 5. So now our next step is going to be, we want to add R1 to the accumulator. So our code to use addition is 0, 1, 0, 1. And we're using register 1. And we do not need to use the data actually for the rest of this, as we have all 3 registers and the accumulator all loaded with data. So I will keep these data switches at 0 for the remainder of this demonstration. So we have 0, 1, 0, 1 for addition, and we have 0, 1 register for 1 selected. So this should add register 1, which has a value of 1, to the accumulator, which had a value of 5. Now we'll do our output from the accumulator, which again is 1, 0, 1, 0. I can turn off the register again. And 1 plus 5 is 6, so that is correct. Now, our next step is to subtract register 2, which has a value of 2, from the accumulator. So we should wind up with a value of 4. The code for subtraction is 0, 1, 1, 0. And like I said, we're using register 2, so which is 1, 0 on those. And again, we don't need data, so let's load that. Output from the accumulator is 1, 0, 1, 0. Again, we don't need the register on. And as we can see, our output is 4. So 2 was successfully subtracted from 6. So our next step is going to be to multiply R3, which has a value of 3, by the value currently in the accumulator, which is 4. So we should wind up with a value of 12. The code to do so is 0, 1, 1, 1. We're using register 3, so we want to turn those 2 switches on. And we can go ahead and load that. And now we want to go ahead and output from the accumulator, which is, again, 1, 0, 1, 0. Turn off both registers, and we have a value of 12. So the value of 4 from the accumulator was successfully multiplied by the value of 3 from the register 3. Okay, so our next step is going to be to go ahead and move the value in register 1 to the accumulator. Make sure that we're able to just do that. So the code to move to the accumulator is 0, 1, 1. And like I said, we're pulling from register 1. So that should be good. And then we want 1, 0, 1, 0. And it shows 1. Lastly, we want to move the value from the accumulator to register 3. The code to do so is 0, 0, 1, 0. We're moving to register 3. So we're going to turn both those switches on and run it. And now we'll check the output from that register. So we'll leave these switches on. And that code, again, is 1, 0, 1, 1. And as we can see, the output from register 3 is 1. So that was successfully moved from the accumulator. So we should be good. That should be everything.